Ooh, symmetry. All right. So we have line symmetry and axis of symmetry. Those two terms mean the same thing. Axis of symmetry sounds a little more sophisticated. So if you want to impress people with your geometry speak, you want to use that term. Um, so all this is when one half of a figure is a mirror image of the other half. So if I have a square right here, we could create, using this square right here, it's the same square, this little dotted line here would create two halves. We create this half and they are a mirror image of each other. So there's a line of symmetry going right through the middle of this square. There's also a line of symmetry going through the middle this way, horizontally. We call that a horizontal line of symmetry. And this would be a vertical line of symmetry. And there's actually two more lines of symmetry if we go from the diagonals. And that wasn't perfect, but you get the idea. And from this diagonal, so from one right angle to the other. So in total, there's four lines of symmetry. So now we're looking at a triangle, and you can see all the sides are congruent, which means this is an equilateral triangle. Um, And again, we can create some lines of symmetry here. These ones maybe are a little bit more difficult to pick up than the square, but if I draw a line right from that angle down to the middle of this line segment on the bottom, I could also do the same thing here. I could go from that angle over to the middle of the opposite line segment, and then finally there's one more this way. So there's actually three line segments, and I'll keep going here, over to the middle of this guy. There's actually three line segments, or three lines of symmetry, I'm sorry, inside of an equilateral triangle. And so saying that our regular quadrilateral, which is a square, and our regular triangle had four and three lines of symmetry respectively, we can come up with a little rule here, and you could test it for a pentagon, a hexagon, etc. But any regular polygon has the same number of lines of symmetry as it has sides. So the equilateral triangle had three lines of symmetry, the square would have four, a regular pentagon would have five, and so on. One other term to keep in mind is rotational symmetry. That's when the figure can get back to its original shape before turning 360 degrees. A square has rotational symmetry. So if I was to move this way, you can see, even though I only turned it one time, 90 degrees, right? I got back to this red line here, and it didn't have to turn 360 degrees, only 90 degrees. So this has rotational symmetry, as you can see. That's an important concept. Any regular figure, by the way, will have rotational symmetry. Just look at one more example here. How many lines of symmetry does this rectangle have? So if you look at this rectangle and try to slice it up, there'd be a line of symmetry coming through the middle this way. There'd be one coming this way, right? That will create a mirror image of the two halves. So there's two. Now this is where this is kind of the wolf. People get a little bit mixed up. From corner to corner, that's not a line of symmetry. And same thing with the other corner, of course. The reason being, if you were to fold this, into halves, and you could try it, you could use a rectangular, actually a piece of notebook paper is a perfect example because that's, a standard rectangle that's not a square. It would fold over the edge. If we brought this into two triangles, this triangle right here would be folded so that this part of your triangle, your part with the right angle, would be over on this end. It wouldn't fold perfectly into a mirror image. Okay, so it would just have two lines of symmetry. And I just wanted to show you some examples of horizontal symmetry, just to pick up kind of on that subject. These all are letters with horizontal symmetry. So C, B, D, E, and X, and X. X does have horizontal line symmetry, but we'll get to that in a second. Then there's vertical symmetry. So A, M, T, U, and V are some examples of that. And then horizontal and vertical symmetry, these letters actually have both of those things.